So once I get my cursor back, there we go, sorry. For the purposes of this talk, the road to Noto begins here with the Rosetta Stone, a 3.5-foot tall tablet that you're probably all familiar with remarkable workings of a hand and chisel, carefully spelling out an imperial decree in 3 different languages, 3 different writing systems, I should say. The stone's historical significance is legendary. I remember clearly a 7th grade world history project where we made a facsimile of the tablet out of modeling clay, and we marked it with our own messages with toothpicks, and we even had a contest to try to translate the messages. And I have the Oak Park, Illinois public school system to thank you for that indoctrination into world writing systems. Anyway, the markings on this tablet are from King Ptolemy V's Memphis decree, given in about 196 BC, during turbulent political times and current cultural upheaval. It's a fascinating example of the painstaking efforts made to produce a document in multiple languages, in this case, hieroglyphics, Demotic script, and ancient Greek, all with the aim that multiple cultures and generations would understand this single message. Fast forward 1600 years to 1573 to Christophe Plantin's Polyglot Bible, printed in Antwerp and funded by the King Philip of Spain. It was 8 volumes, 6 of which were the different books of scripture, and then 2 translation dictionaries to accompany them. The translations were in Hebrew, Greek, Aramaic, Syriac, and Latin texts. The typography is stunning in beauty and simplicity, and the painstaking planning it takes to put all of these scripts on a single page with an accompanying translation right next to it. This particular spread shows Hebrew on the left, a very upright looking rectangular script, and the Latin is set in an upright Roman, which complements that, that aesthetic of the Hebrew. On the right side of the page, however, you have a very cursive Greek, and that is set in an italic Latin to sort of complement the curvature, and it really brings a lot of harmony to the page. And then you can see that harmony in this detail quite well. You can see the on the right side, the italic Latin is very exuberant. You can go down the page and count, I don't know, something like 10 different ampersand symbols, very exuberant and similar to the Greek, which is a very exuberant and lively running text. And the printing is astoundingly crisp. About 70 years later, in 1657 in England, Bishop Brian Walton began work on his Polyglot Bible. He published 9 translations: Aramaic, Hebrew, Syriac, Arabic, Samaritan, Ethiopic, Greek, and Latin. And this production was funded by subscription rather than a grant from a government or church body. And in just a year, there were 400 contributors that were standing in line waiting for this book. And some consider it the least beautiful of all the Polyglot Bibles, which I kind of disagree with. But it may be because it was not a royally funded project with a commensurate royal flourish, or maybe because the complexity of setting by hand 9 different translations versus the 4 or 5 of previous works. It really challenges the typographer to assemble a harmonized page. For me, the achievement here is the complexity of the formatting, and the quality of printing is just inconceivably beautiful, particularly compared to where we are 400 years later with your insurance explanation of benefit statement. This is a polyglot page. It's now very commonplace to see this in institutional documents. However, this solution can definitely be improved upon, like many other typographic problems. The line lengths are too long for many of the scripts, and the variety of type styles makes it appear like a ransom note rather than a document from a well-branded company or institution. Some of the bolder types make them look more important than some of the other scripts, and makes the page look not very egalitarian. And from what I experience quite a bit now is branding. The branding falls apart because the BMC HealthNet brand is somewhat degraded by the fact that none of these scripts really look like the brand voice. I don't want to negate the complexity of going on behind the scenes to make this page possible. There's an awful lot of computing power that the reader will never or should never really know about. Just the ability to shape left to right and right to left scripts on the same page was a huge step in computing. However, pages can get even worse than this. An author's worst nightmare may be for a reader to come upon his page and have it look like this. This page is full of missing glyphs, and I apologize for the quality of the image, but I received it from Google's Bob Jung, who orchestrated much of the Noto project from the Google side. If a computer system is missing a character that is entered by the author, the reader sees the undefined glyph, the empty square. And as Bob Jung put it, the squares remind a lot of people, particularly in Asia, of packaged bean curd or tofu. And this is where Noto got its name, no tofu. It took me months to understand this before I knew why they came up with the name tofu. So it was an epiphany for me. So for me, the road to Noto started in 1985 when I started at RIT's School of Printing. In my typography classes, I was introduced to hot metal typesetting juxtaposed to the latest computer equipment of the day. My professor, Archie Provan, was working as a consultant to Xerox on their efforts to gather bitmap fonts, these monochrome, jaggy bitmap shapes, from all these different font foundries to cover all the languages in the world. He was working with a gentleman, Ed Smura, on the AFI standard, the Association for Font Information Interchange. This included many different aspects to typography, including typeface classification and typeface groupings, but this bitmap part of the project was probably the most ambitious. With these bitmap fonts, the Xerox Star publishing system, which was sort of a precursor to the Macintosh, was to be able to produce documents in any language. And the dream was that you'd be able to upload these bitmaps to a satellite and beam them to any Xerox Star anywhere in the world and duplicate your document. When describing this project to the students, Archie gave a very romantic notion about how if people around the world could communicate accurately and more easily, they might spend less time fighting. And homely as these were, these monochrome bitmap shapes would carry the power of our own messages, our own Memphis decrees all around the world. By the time I graduated RIT, vector fonts or PostScript fonts were being used and being more viable. So basically, single-size, jaggy bitmap fonts were no longer sufficient when you wanted to create expressive typography. So I began working on the TrueType system fonts for Microsoft in 1990, and the fonts all had a modest character set of around 300 characters, and that was already more than earlier font formats could handle. Fonts could do this because Unicode became the standard way of encoding or organizing all the letters and all the alphabets in the world. Previously, ISO 8859 was the encoding scheme used, and it only allowed 256 characters in a single binary font file. With Unicode, every character in the world gets a unique identifier. The gbrev for Turkish gets the name gbrev and a Unicode ID. And similarly, the omega for Greek gets a name and a Unicode ID. But obviously, the Unicode registry is constantly being updated. In 1999, for example, the consortium scrambled to put the Euro into its directory, so fonts like Monotype could update libraries of hundreds of font files to include the Euro symbol with the proper Unicode. Between 1990 and 93, font foundries continued developing a steady stream of ever-growing in size Unicode encoded fonts. The WGL, or Windows Glyph List character set, defined by Microsoft, extended the expectations for users that a font will have support for about 90 languages. Bigelow and Holmes built their Rosetta Sans Unicode font to coincide with the publication of Unicode's 1.0 specification. Rosetta Sans Unicode was released by Microsoft in 1993, and it could be the first Unicode font to include Greek, Cyrillic, Hebrew, and Latin character sets. Additionally, the font included support for phonetics and math symbols, which were all part of the Unicode 1.0 spec. In 1997, Monotype was tasked by Microsoft to extend Arial to cover all of Unicode 2.0, a mere 50,000 letter forms, weighing in at about 22 megabytes for a single font file. While the TrueType font format could theoretically support all of these languages, characters in all these languages in a single font file, it was a very tricky process to sort of stitch together all of these Unicode code pages into a single font file. My colleague of many years, Kamal Mansour, saw to it that the design was, as much as could be expected at the time anyway, to be harmonious with Arial. We included many more Chinese ideographs than were defined by Unicode. These extra glyphs were included to support both simplified and traditional Chinese. So the actual number of letter forms in the font exceeded that of the Unicode standard. This illustration kind of shows how you have two separate glyph shapes that represent the same Unicode code point. Similarly, in Western eyes, you may have a lowercase g that has two loops and a lowercase g that has one loop, but both those glyphs represent a single Unicode. And this is how traditional and simplified Chinese reconcile their different way of reading Chinese. And here the Rosetta Stone makes its appearance on the cover of the Unicode 2.0 standard. At this point on the road to Noto, we still have about 20 years to go. In 2006, Google approached me to create a typeface family for a new mobile phone platform called Android. Google wanted a unique UI experience for the branding of Android, and this, of course, starts with a unique typeface to interact with. Because Google's unique brand and they really needed a fine degree of control over how the type worked in the environment, the typeface had to be designed in tandem with the development of the first Android devices. And recall that cell phones from 2006 didn't have anywhere near the resolution that we have on cell phones today. So because of Google's and Android's somewhat quirky branding, I needed to draw an approachable typeface that was sort of left of being neutral. That is, being too neutral wouldn't make it stand out as being unique to the Android brand, but if it was too cute, the legibility and functionality would suffer. And also, as I mentioned, the cell phone screens were of much less quality than they are today. The pixel density wasn't anywhere near what we have today. So the thin parts of letters can look like they're disappearing on one screen and look too heavy on other screens. So it all depends on how the software interprets and draws the letters. So with this in mind, I went ahead and started drawing some letter forms, and these letter forms then were made into actual font files to install in devices to actually look and see what the result was. It was a little touch and go because the original user interface was just being hammered out at the same time the typeface design was being done. So you would take these test fonts and view them in these test screens, and you'd be able to tell if there was enough contrast between the regular and the bold, or whether the X height was too short or too tall. I made sure that the detailing in each design was working well at these limited resolutions. And once we were on the right track with the actual typeface design, we had to do a lot of weight tests to see how much contrast was necessary when you would have just a regular and a bold weight. So when you only have two weights of a font, you have a challenge in building a hierarchy in a user interface. You want to have the certain elements of the user interface to stand out and some to recede. So working with two weights, they had to be spot on for how bold and how light they should be. After some discussion, it was determined that a serif typeface would also be part of this basic set of fonts. The serif would be for reading news feeds and extended text, and the sans serif would be for user interface elements like buttons and menus. Then all the fonts had to support this WGL character set, which Microsoft had defined over 10 years earlier, 15 years earlier. So it was kind of a, this was sort of the standard that we were working for in terms of language covered, about 90 different languages. The goal of all this, of course, was to create a family of fonts which held up at small screen sizes and gave the platform an approachable and friendly appearance. And we may actually have achieved this as a writer for Wired's online edition called the fonts Googly. But when the time came to expand on what could be displayed in the Android UI, Google thought it was clear that they did not want something that looked like this. This is similar to the explanation of benefit statement I showed you earlier, where it's kind of a mishmash of different sort of writings, different writing systems, but very different than the Latin. So they don't look like they're harmonized or support each other. This was the look that we wanted to go for, something that was harmonized and contemporary and ergonomic for all the different languages. Making a harmonized design for scripts which have no historical relationship to each other is a bit tricky, and in some cases, nothing but a compromise of making things similar in weight and proportion is about as far as you can get to bring them in alignment with each other. In Arabic, for example, the weight is on the horizontals rather than the vertical stems, like they are in Latin. So this alone makes an enormous difference in balancing the weights. You can take visual cues from the Latin and pick them up in the Arabic. So for instance, these blue dots show the softer terminal endings, or the ball terminal endings, and the contrast of thick and thin shapes. So they can start to look like they have some of the same DNA. This is the Arabic style called Nasq, which is used typically when you're using a serifed Latin. Usually in a Nasq style, those apertures inside the Arabic forms are very, very closed, and sometimes closed all the way, and can be very difficult to read at low resolutions. So we exaggerated those sizes so that they could be read on a cell phone. Here you see the Droid Sans Arabic, which is in a Kufi style. It complements the Latin sans serif more closely. But typically, however, Arabic readers prefer the Nasq style for extended reading. There's sort of a parallel in Western readers where it took up until the 50s or 1960s where people would really not want to read a book set in a sans serif typeface. So this, I think, there may be a component of Arabic readers which will ultimately, a generation from now, maybe they'll be more comfortable reading a sans serif style, just as we have here in the West. But working on this project, I learned that Arabic readers were very accustomed to having to pinch zoom text as soon as the page is loaded. So one of the goals of exaggerating the proportions of the Arabic was so that the readers could skip this step. If they loaded a page, they could read it immediately, or they wouldn't have to zoom into user interface elements to read the Arabic writing. And my understanding from Google anyway was that this was achieved in Droid, and something that we brought over into the Noto fonts later. So one of the other styles early on that we had to consider was Thai. And Thai is a pretty complex script vertically compared to Latin, which has more of the detail horizontally. But the characters get very tall and need to be scrunched into fit within the Latin proportions. But you can see the visual cues that I brought in from the Latin into the terminal shapes of some of these Thai characters, where they have a very soft, almost a very soft bulge at the end of them. There's a sample of the Droid Serif Hebrew, another script where the challenge is in the weight distribution being opposite to the Latin. But again, these were drawn to be harmonious in proportion and color. The Ethiopic script was drawn by myself and Jim Wasco. Ethiopic is often seen in a slanted form, almost like an italic. But we decided that for a sans serif, we should make it upright, and it will help legibility in a user interface. And this was pretty well received as well, as far as the decision goes. Armenian takes many clues from Latin shapes, and it's considerably easier to harmonize than some of the other non-Latin scripts. And similarly, Georgian takes many cues from the round shapes found in the Latin, but it has an entirely different texture than the Armenian. It's very round and loopy and soft versus the upright stature, or the vertical stature of the Armenian. But it's clearly a member of the Latin typeface. So some of you may be wondering why I'm talking about Android at this point in the road. In 2009, I was asked to adapt Droid Sans into a branding typeface for Chrome. This design became Open Sans, a slightly wider proportion version of of the Droid Sans. And roughly in parallel to this, the Chrome and Android groups at Google were discussing the idea of combining their efforts on a development of a super font, which would cover all of Unicode. The issue of tofu was cropping up often, obviously, because as the internet became more widely used and more translations were being put into web pages, tofu was becoming more common, and they really wanted to stamp out tofu. So Open Sans, the branding typeface for Chrome, then became Noto Sans, and the Droid serif typeface was then brought into this project of being a serif, Noto serif for world languages. By 2011, it was decided to expand the Latin family so that it would include a full typographic palette of styles and weights and widths. So the sans and serif style would have condensed and narrow versions added, additional weights from thin to black, and an added range of contrast. You can see there's a very, very high contrast version of Noto serif on the third line there. So that's about 72 styles per family of type. And Unicode, by then, it accounted for around 3,400 characters to support Latin, Greek, Cyrillic, and phonetics. This complement of characters supports over 500 languages on its own. So the additional characters being added and all the additional weights and widths being drawn meant we had to draw about 230,000 characters to meet the expectations of the Noto project. Additionally, the goal was set for full Unicode coverage for Unicode 11 by 2018. So this meant about 130 writing systems, or scripts as we call them, which would allow you to read about 800 different languages. And some of these listed in this on this page are dead scripts, out of use for hundreds of years, sometimes more. But these all serve a population of readers, whether they're just researchers, linguists, or the entire country of Myanmar, or all the islands that make up Malaysia. All of these native scripts are included in Noto. By now, it was more than clear that Noto would never ship as a single font binary with all of Unicode. We just think back to the Arial Unicode was already 22 megabytes with 55,000 characters. We had so much more going by now. So the fonts are built as individual modules to cover maybe one or a couple of related Unicode ranges. Another reason was that the writing systems covered beyond Thai become quite complex vertically. I mentioned this earlier. You can just about get Thai to fit within the vertical proportions of a Latin font. But then you can see on the lower left, Javanese with its extremely deep descenders, and on the right, Khmer with a lot of detail in the vertical direction. You really do a disservice to the reader to try to scrunch all this into a vertical proportion, and it makes it very difficult to read. So providing them as individual font files helped us get past this notion of trying to squish everything into some Latin vertical dimension that was determined many years before this step was taken to add all these additional scripts. Another example is the Nastaliq style of Arabic. While the commonly used Nask follows a flat baseline, you can see on the top two lines, Nastaliq, the baseline shapes downward to the left. So The longer the word, the taller the dimensions are. So you start in the upper left and descend to the upper right and descend to the lower left. The longer the word, the taller the dimensions. So Nastaliq was added to support Urdu, Pashto, and Persian, and is another big breakthrough in terms of the complexity of how this script is shaping. One of the ways we look at an enormous project like this is to try to break it down into logical categories. This is just kind of one example. It's not the way we did it entirely, but you can see, for example, in this image, all of the orange boxes represent dead scripts or scripts that are no longer used. The green scripts are all Indic scripts, for instance, used in the Indian subcontinent. So once you break it down into pieces like this, you can start to help the project managers find experts in these local areas, or linguists to work with, or designers who specialize in these specific areas. So as an example of a dead script, cuneiform could be as old as 5,000 years. It's not in practical use, certainly, but useful for scholars and linguists to have an encoded font file. It's also one of the things that is very interesting to me about cuneiform is it's really a three-dimensional alphabet. It's the depth of the stylus into the clay, as well as the width of the characters. So this has to be sort of mimicked in a two-dimensional form in a font file. Another example of a dead script is Anatolian hieroglyphs, at least 4,000 years old, predating Egyptian hieroglyphs. So when we drew these, we were thinking about the soft, more worn, more crude, smoothed over looking shapes versus Egyptian hieroglyphs, which are very crisp and have a much more refined design. As I mentioned earlier, about complex scripts in the Nastaliq, many of the scripts used in the Indian subcontinent are considered complex. And what I mean by this is there's a shaping that happens beyond encoding individual letters in Unicode. You can see the word Hindi on the right. As you type the first two blue letters, they rearrange themselves. You type them left to right, but then the stem with the matra over the top gets shifted to the first character. You type the green character and the pink character, and they all of a sudden assemble to form a ligature on the third line. And then in the fourth line, you can see how the matras, the loops on the top of the characters, change in length slightly to connect to the character below. So this is all going on to more beautifully render the word Hindi. It's legible in the first line, but it's not how a Hindi reader would want to see it done. Yella Bosma was monotypes creatively in creating the Indic scripts, and I believe he's actually working on some updates for Unicode 13 as I'm giving this talk. But there's an immense amount of work that he put in. The Indic writing systems appear quite different from each other, but they've been designed to harmonize as much as possible. You can see Devanagari contrasts quite a lot to the very fluid Sinhala, but their color and proportion are preserved to keep them in sync. And Yelle was very much behind making the decisions that would keep these very different looking scripts harmonious. The same with Telugu and Tamil. They contrast a great deal in overall texture, but their proportions and color tie them together. And just as I mentioned that there were technical issues to resolve way back with Arial Unicode, the same was true with Noto. This is my colleague Toshi Omagari having to reorient his laptop in order to design Mongolian. This is a script that connects vertically, and it reads top down, left to right. So it's similar to Arabic in that it connects, but it's connecting vertically. And the tool developers for Glyphs app were incredibly supportive in updating their products to make it possible just so Toshi could reorient his screen to normal and create a beautiful Mongolian Noto. Now, I mentioned a bit about dead scripts. On the flip side, this is Adlam, a script that was developed in the late 1980s by two brothers, Ibrahima and Abdullahi Berry, to describe or to transcribe the Fulani language spoken in Guinea, Nigeria, and Liberia. Previously to Adlam, Fulani was written in Arabic and Latin, but they developed a way of writing the language, and it was adopted by Unicode as recently as the 90s. So this is where we were in 2018 when Noto fonts covered nearly 64,000 characters. But in the last 2 years, there have been many updates, including new Unicode scripts, I think 4 new scripts, and as many as 5,000 new characters. So we're still working and developing and releasing new updates to Noto. And what could possibly be left, you might ask, in terms of what's missing from Unicode? Now here's 2 examples: Khitan, a language that was once spoken in Manchuria on the right, and Khwarezmian, which is an ancient language of Eastern Persia on the left. Sutton sign writing is a notation system used to teach sign language. It requires thousands of icons necessary to show hand gestures and facial expressions, all of these that are used by sign language interpreters. So they have an actual documented way of learning how to do to do interpretation. And that's not a box of French fries on the far right. That's actually the palm of a hand with 4 fingers oriented in the way the interpreter would give the sign. And on the bottom, the Noto symbol font is getting many new characters, including the long-awaited accordion and fondue dish. The list keeps growing. Noto will continue to be polished and refined to reflect the demands of the community of people using the fonts. In addition to about 30 people within Monotype that have worked on Noto over the years, we've been working with about 30 outside designers, linguists, and consultants around the world, including Fiona Ross, Tiro Typeworks, and Kigali Design. The community of users and testers who have provided feedback is, of course, even larger, and it's an honor to be working for them to make it this enormous undertaking a possibility. In the end, Noto may not be used for retranslating the Bible or imperial decrees. It might be very simple messages that we can convey with this enormous tool that we have at our disposal. And maybe Noto is another step towards that romantic notion I heard as a student, that people around the world could spend more time communicating instead of fighting. So again, I want to thank you all for attending and for the privilege to kick off this wonderful, wonderful conference.
Thanks very much, Steve. Beautiful lecture. And do you want to take some questions? There are quite a few coming up on the chat line.
Yeah, absolutely. I'm happy to do that.
I guess the first simple one is the one that everybody has, which is, will Noto ever talk mathematics?
Yes, of course. Yeah, go ahead with the question.
Well, I mean, this is the first question. I mean, it's not just a question of symbology, but also a question of delimiters and extensible delimiters and so forth. And which,
sure. Yeah, I mean, that's really up to Google whether they want to sort of support a specific or, you know, a specific math markup of some kind. At this point, it's really the goal has been to support what Unicode is encoding. And then from there, you know, there were discussions at one point about putting in the open type support that Calibri uses for math markup. So I really, it's out of my hands to make that kind of a decision. We'd, you know, certainly be, you know, really excited to be able to take on that endeavor of supporting whatever, math notation. But at this point, it's like I said, it's kind of out of my hands.
Okay. The second question is would that be extensible to other areas of science like chemistry and astronomy, even if it is outside Unicode?
If it's outside Unicode.
Yes.
Yeah, so the fonts with the licensing capability, I believe proposals can be made to Google to do whatever augmentation people would like. But I'm not sure if there needs to be a formal approval given, but certainly the characters are there for people to use in whatever manner their imaginations will take them.
Okay. The third one is, will there ever be a version of Noto for printing different than for e-reading?
So the designs actually, there's actually two versions of almost all the mainly used scripts. A user interface version, which is somewhat condensed vertically to help make it possible to make buttons in whatever complex script, say for Khmer or something. But there's also a document version, and the document versions are made for producing physical documents. So in other words, they may be more comfortably proportioned vertically to be more traditional in how they appear on a printed page.
We have another question. Is there any handwriting that goes in the production of these digital typefaces that you know of? Or is the process all digital?
Oh, yeah, almost everything is drawn before it's digitized. Depending on the complexity of the script, for instance, I can think of Myanmar, for instance, which has very geometric base forms. Much of that can be done straight digitally. But other scripts like Adlin, for instance, the newest script, there's documents showing how the brothers proposed writing these shapes, and so obviously, having to draw them in the the direction, and it's like learning calligraphy. You do this stroke first and this stroke second. So that's how the type designer approaches digitizing the typeface, or drawing and then digitizing the typeface. So yeah, there's quite a lot of drawing involved.
Next question. How do you see going ahead with variable fonts within the Noto family?
Yeah, the fonts are basically, I think, in most cases, variable ready. There hasn't been a request to make actual variable font deliverables out of any of these yet, but they're certainly set up in a way that they could be made as variable fonts.
A very simple question. Can the Rosetta Stone be recreated with Noto right now?
I believe everything is there to do it, yes. Better than my toothpick rendering on my clay tablet when I was in 7th grade. I'm sure you could do a much better job with Noto.
Okay. And a longer question. Latin fonts people have a very wide choices of font families.
Yes.
Given the amount of work taken to produce Noto, will it be feasible for others to do something similar? Or will multilingual printing move to a Noto only monoculture?
Well, I think that's the point of doing Noto, is the fact that you have something now as a basis to work from that's been reviewed by people who are culturally either native speakers or studied up enough on these scripts to form a basis to work from. There's an encoding to work from. If you're drawing a script for, say, Tagalog or Old Chiki or some other minority scripts, you can actually have Noto as a basis of how to encode the font and how the forms will look as a basis, but not certainly restricting typographic interpretation and typographic freedoms. You sort of have to, you have to walk before you run. If a culture does not have a rich history of typography, they now have a basis to work from to develop new imaginative scripts that represent those languages and scripts.
The next question comes, do you have an estimate of how much FTE took Noto so far? Full-time employees.
Full-time employees, yeah, there was about, like I said, there's about 30 within Monotype and then about 30 outside consultants. I mean, there have been people who've retired during this, the span of this project. So the numbers keep changing and new people are adding to it every day. So it's kind of a, it's definitely a moving target.
Right. Well, most of the other people are saying, thanks for such a beautiful talk.
Well, I appreciate that. And I really appreciate being asked to speak. And I hope there's some good takeaways from what I said. And I'm really encouraged to see, now with more adoption of Noto, that question about, new typefaces being done in all these exotic languages outside of Latin, I think is really the whole point, is setting this basis. And I'm, really looking forward to, looking beyond and seeing what people do with new type designs.
Thank you very, very much.
Thank you.